Okay, so if you are watching this video, I am assuming that there's another video somewhere that tells you how to get all this stuff set up. So I'm assuming you've already got access to GitHub. You already know how to use the terminal. You already know how to run tests. You're comfortable compiling C++ and debugging in whatever operating system it is. I will not be helping with that in this video. That will be somewhere else. But assuming you've made it to this point, um, this is what you're going to be looking at for the very first homework assignment. So the first, well, programming assignment technically, the very first thing that you're going to see when you're looking at the assignment is what's about a 15-page technical documentation, starting with, some hints about maybe how you would approach this assignment, and then descriptions of each function that you are required to implement. And then I think at the end there might be some links or something. Yeah, and then so further reading in case you get stuck somewhere, and then some instructions about how you actually build the tests and run them and such. Uh, so what I'm going to be doing today is I'm going to be walking through this documentation at the same time that I'm walking through the actual starter code that we give you. I'm going to be pointing some things out, making some notes, and kind of explaining some concepts that I have seen students struggle with in previous semesters. So let me go ahead and I'm actually going to switch to my iPad real quick if I can figure out how to do that. Okay, so this class is called data structures, right? So I hate to be, giving you the 10,000-foot view, the bird's eye view, but what is a data structure, right? So a data structure is just some agreed upon method of storing information such that it can be retrieved, accessed, manipulated, so on and so forth in the future, right? And so the most obvious and simple data structure that we're starting with, um, well, you would probably say is the array, or one evolution past the array, which is the vector, right? So before we get into complicated stuff, if you have information, theoretically, you could just store it all consecutively. And so that's what the array does, right? So on your computer somewhere, you've got a disk or some kind of drive, and on that drive, you have places in memory that are going to have some address, so it's going to be some hex code, some nonsense, right? And the most obvious way to store information is just to do so contiguously, right? So as you need to store information for your purpose, whatever it is, you just do so continuously, and that is an array. And so if you've taken an introductory programming class, you probably know that that causes some issues, right? Because what if you have an array that has data in it and you want to insert something here, right? Say we got an array of x's and you want to put something in the middle. Or another common problem is, what if you allocated a certain contiguous block of memory, but now you need to add stuff in the region that you did not allocate space for. Well, all of that stuff, you've probably seen these issues before. As a programmer, you shouldn't have to worry about those things. And the solution to the complexity of actually dealing with contiguous memory is called the vector. So the vector you can think of kind of like a black box. It's an abstract thing that'll keep track of the size of an array. It'll keep track of the capacity of the array. It'll keep an actual pointer to an array itself. And then all of those functions that I just mentioned, inserting, erasing, adding extra available capacity, just going to call that logic. All of this stuff is going to be neatly and tightly wrapped up inside a class, such that every time you need an array to store something in memory, you don't have to reinvent the wheel, right? So let me make an analogy to make that more clear, right? So I assume most of you have cars or driver's licenses or whatnot. When you need to get from point A to point B, you don't build a car to do so, right? You don't assemble the transmission and the spark plug and the catalytic converter every time you need to go to the grocery store. You just get in your car, and some other engineer previously has built the car in such a way that you don't have to worry about those things. As a programmer, if you need to get from point A to point B, or in our case, storing some information, you don't need to build an entire data structure to do so. You can leverage something like a vector that has already been built for you. C++ actually has a vector that's available in the standard library. So you might be wondering, like, okay, well, this vector is this awesome thing that somebody else already built that already exists. Why are we studying it? Well, unfortunately for you, you are an engineering student. So if this was our car, right, and we don't care about the insides, we just want to go from point A to point B, this logic would kind of be like, this would be like the engine, right? And so again, unfortunately, you are an engineering student, so you are studying the engine. That's what we're doing in this assignment. So as a programmer, after you pass this course, you will be able to use a vector for any purpose you want and never have to worry about any of this stuff that's on the inside, right? That'll never concern you ever again. But for now, we're studying how you would go from having the array that is clunky to the vector that is elegant and simple and completely abstracted away. So that's kind of like the bird's eye view, the high level view of what we're actually doing with this assignment. So let's look at the code. So I'm gonna skip this introduction. I did my own introduction. Please go read this if you're curious. So for each of the functions that appear in this assignment, in chronological order, so as they appear, so the first thing we see is this constructor. Its corresponding information will appear on the technical doc, right? So this constructor is the first one. You can see this next constructor is the next one. So they actually do go in order for this document. As you can see, what we're looking at in vector.h is a class. So the vector class, which is like the box that I just explained, is going to house all of this stuff, which is basically like the engine, the transmission, all of the inner workings, and you're going to put those pieces together so that hopefully another programmer could use this thing that you've built and not have to worry about all of the details of keeping track of an array. So quickly glancing through here, we've got our constructors, destructor, assignments defined. We've got an iterator, which we'll talk about this later. This is new. We've got some easy one-line functions that just return values. We've got our logic for inserting and erasing, our logic for actually expanding capacities here. We'll talk about this later. And then we've got a new concept, which is an iterator class, which, as you can see, this is actually a subclass because this class definition right here is actually inside this outer class definition. So it's a class that's scoped to vector. Again, we'll talk about this later. We've got a clear function and then some stuff to make it compile. And yeah, so let's go ahead and get started with the constructors. So by the way, the order in which I'm talking about stuff in this video is kind of loosely the order that you should start implementing this stuff yourself when you're actually coding. It might not be one-to-one, but it's kind of relatively in that order. So the first thing I would think about is your constructor, and this one is actually your default constructor. So let's look here at the documentation on the left and see what it tells us. So we've got a description that says create an empty vector, parameters none, returns none, time complexity is O of 1. We'll talk about this later. And these are the tests that will be relying upon this to be correct. And this is not an exhaustive list. There's probably more tests that actually need this to be implemented, but anyways, let's go ahead and talk about these. So the default constructor is going to be called in your code anytime you do something that looks like this. So anytime you call a vector, and for now, let's just pretend that it's an integer, and you name it something. So my vector. So if you in your main function in code or whatever it is were to write this line, vector int my vector, the compiler will then go to this function to determine what happens. So what happens when you start an empty vector from scratch? Well, you probably need to take care of the private members is what I would assume. So on the diagram that I made earlier, your vector is going to keep track of capacity, which is how big is the array, size, which is how many elements are stored in the array. These are two different things, right? So capacity could be like 8 and size could be 5, right? Size can't be bigger than capacity, right? And then we have a T star array. T is the templated data type. So theoretically, this vector would work for integers, doubles, Any type of data type should work fine here, and we have a pointer to an array. So initializing a default constructor, think to yourself, what do these values need to be if I have specified nothing? Well, capacity and size are probably 0, and array is probably a null pointer. So go ahead and code those things. Let's go a little bit further. We have a parameterized constructor, so I'm going to call this param constructor1. And let's see what this one says. So I'm not going to go in complete depth for all of these, but it says constructs the container with count copies of elements with value. So if we were to do something like vector, and I'm going to call this one a char this time, my vector, and if we were to actually pass it parameters, so let's say we're filling it with characters A, and we're going to have 42 of those characters. Well, we need to handle the logic. So if you were to write this in code, if a programmer said, hey, I need a vector, every character needs to be A, there needs to be 42 of them, and they wrote this in code, the compiler would look at this place to determine what needs to happen. So in this function, you've got to fill up array with 42 A's. Should be capable of doing that. Figure that out. The next constructor that we have is going to be the parameter constructor2. Go ahead and call that. And this one is a similar idea. It just says constructs the container with count default inserted instances. So if someone were to do vector double my vector, and they just gave you a quantity and didn't say what value it should be, compiler would look here. You see this is maybe a new keyword, explicit. If you're really interested in C++ syntax, go look up implicit type conversions. Otherwise, don't worry about it. Okay, so that's where I would get started. This is kind of what I've talked about so far. Let's see. So once you've done the constructors, these test cases might not actually pass at first. I'm going to go ahead and label these. So this is your move constructor. And so do these first 3 constructors. Save the rest of these. So move and oh no, this is copy. Oops. So save the copy and move constructor and then copy and move assignment for the end, probably. So actually I'll comment these out when we come back to them. This is your destructor. So destructor. Essentially this is going to deallocate memory. So if you have an array that points to dynamically allocated memory, just take care of that here. And so once you've got these 3 constructors, you can start running tests on them, and you'll probably need a few of these one-liner functions. So let me go ahead and scroll down in the documentation. So the first of the one-liners is going to be empty. As you can see, it just returns a Boolean as to whether or not there's anything in the array. And these should be really easy. So I actually recommend that along with the constructors, you just knock these out right away. Like if you have some size variable, if you say size equals 0, that's the thing that you need to return, right? Like, is there something in this array? Size, again, just return size, capacity, return capacity. Should be pretty easy. Next here, we've got another block of what should be mostly one-liners. I'm actually going to separate this. So size, pretty easy. Capacity is easy. We've got the at operator. So if someone were to do like my vector dot at 2, they're requesting the elements at position 2. If 2 happens to be greater than the capacity, instead of causing a segmentation fault because you have an out of bounds access, you'll throw an error instead. So I'm going to say think about throwing error, and I think that's defined actually in the docs here. So it says access element at position with bounds checking throws std out of range if it's out of range. So throw the error if you need to. And this is more one-liners. So I would just knock out this stuff right away because you don't know what test cases are going to depend on this stuff. So yeah, as soon as you're starting the assignment, think about what do you do when the vector is getting initialized, so how do you start things, and then how do you handle the very basic input output operations kind of. So that being said, I think the next thing that we need to talk about is the iterator. So I'm going to go ahead and actually switch to my iPad once again. All right, so I'm going to make an analogy. So vector is to array what iterator is to pointer, right? So what I said before is that the vector is a way of abstracting all of this stuff. So really on the inside, what you've got is you've got an array and a bunch of logic for handling that array. And because there are different functions that you would have to do repeatedly, instead of building the car to drive from point A to point B, you rely on a car that's already been built. And due to the nature of this class, we are studying cars, we're studying the engine, we're studying the parts on the inside. I want you to think of iterators as being essentially the same idea. So if a vector is a car, an iterator is also a car. Iterator. Or maybe think about it as a component within this car. And so instead of keeping track of size, capacity, and an array, an iterator is only going to keep track of a pointer. So pointer. And then like we had before, there's going to be some logic. So some logic for manipulating that pointer. So whereas the vector was responsible for the array, the manipulation of that array, and the idea is we want to do all of these things under the hood so you never have to worry about them. The iterator is a pointer and every function that you would want to do to a pointer, right? So imagine we want to get to the next pointer. We're going to define iterator plus plus. Imagine you want to do iterator subtraction to find the difference between two pointers. Well, that's going to be defined as well. So all of these potential functions that you would need, just like for vector, we have like maybe we need the size or maybe we need the insert function, right? For the iterator, that's basically think about it as a pointer along with every function you would ever need to do to a pointer. So iterator, vector, I hope that that's clear. Um, as we approach more difficult data structures later in the year, you're going to see that iterators become super useful. Like when we're talking about graphs or maps, I'm getting ahead of myself. As soon as the complexity of these structures, hits a certain point, the iterator is going to be completely necessary. Maybe you could scrape by building a vector without defining an iterator, but it's good to learn while the conditions are easy. So as soon as you've done your constructors and your one-liners, you should be passing some of the test cases, definitely the constructor test cases. The next thing I want you to do is complete this class. So as you can see, it's a class that's scoped down here, and we've got some methods. So let me scroll down in the technical documentation to where this is. Okay, so this part of the technical documentation is going to be referencing this stuff. So as you can see, we've got a pointer that is a private member. Just like before, we had an array that was a private member, as well as a list of every function that you would possibly ever want to do to a pointer. That way we define it here, and we don't have to actually build the car to go from point A to point B, right? So the first thing that we've got here is we've got our iterator constructor. So how would we, so constructor, and let's see, where is that? Okay, that's actually not on the documentation, my bad. So if you've got a blank iterator, should be a pointer to nothing, right? Probably. So pointer is equal to null pointer. And then we've got this parameter constructor. So if we already have a pointer, how do we wrap that with all of the functions that we need? So this is going to be used later in begin and end. So maybe keep this in mind for later on, right? Because that's like saying if we have a pointer, we can construct an iterator. And that would look like something like this. So iterator, and then we pass a pointer, right? So that's that. And then we're going to have, like I promised before, all of these operations that you would potentially want to do on a pointer. So the first one is dereference that pointer. So this one right here will be, return dereferenced pointer. And then the next one is the arrow operator. So just return pointer. And I'm not going to go through these all of them. I feel like the tech docs are pretty solid on all of these functions, but I will give you an example. I'll throw you a bone just to get started. So if we have a pointer and let's say our goal is to increment that pointer, we've got two different ways of doing that here that are defined in this little block. We've got the prefix increment, so that would be doing something like pointer plus plus, I think would be this, something like that. And essentially what the prefix increment is doing is it's incrementing the pointer and then returning star this. If you're not completely familiar with C++ syntax, this is a pointer to the current scope, the object in the current scope. So star this would be returning the actual iterator itself. And then for postfix, I personally, when I took this class, I never would have thought of this in a million years, so I'm throwing you a bone. Iterator copy is equal to start this. This is a little hint for how you get started. You're gonna actually need to make a copy of the current iterator, increment the current iterator, and then return the old copy. So let's see, increment this iterator, return copy. So hopefully that should get you started on the iterator. Hopefully you understand the iterator's purpose. And so once you've done the constructors, the one-liners, I would knock out the iterator class entirely. And so once you've done the iterator, I would say probably the next thing you want to do in your code is move on to the insert function. So let me find these in the technical documentation. Okay, so insert starts here. Oh, and by the way, I would not start with pushback, pop back, because we're gonna do a little trick. I'm gonna show you a little trick in a minute. Okay, so this is your insert function, and we actually have three of them. The first one is your normal vanilla insert. Your next one is gonna be insert with move, and if you don't know about move, we'll talk about this in a second. And then the third one is your insert multiple. Yes, I can spell. So after you've done iterator, I would then move on to finishing these three functions. And as you can see, based on our different conditions, there might be different information that we would want to specify when doing insert. And let's see, in the tech docs, it says about the same, and then also it gives you the names of the test cases that are going to be testing these things. And so let me go ahead and let me switch to my iPad so that I can actually explain this stuff. Okay, so imagine we've got the problem that I specified before, right? We've got some block of memory. And let's say that we've got stuff in this memory already, and we want to insert at this position. Well, if we're using the tools that we had before, which is just this vanilla array, then we are going to have to write a lot of logic to put something in the middle here. Let's say we're trying to insert at this position. We have an iterator that points to this position, and let's say we call my vector and we call insert at the position it, and let's say we want to insert 5, right? A number. To do that, we're going to have to actually shift these elements over to make space. And so as a huge hint, when you're implementing the insert function, I highly recommend that you start when you're trying to make like what essentially would be like a hole in the array. So actually, let me do this. 1, 7. So what the finished state is going to look like, we're going to move the things that were in the way, we're going to move them over, and then that'll give us an opening in the array to which we then insert our desired value. I highly recommend that when you are moving things over, you actually start from the back. So start from the back of the array and move everything over one. So move like so, and then let's see, 3, move this over, and then 2 move this over. And sorry for the speed of this animation being a little bit slow, but bear with me. And then voila, we've got our empty space to which we put our value. If you were to go the opposite direction, this is a very common bug that I see students run into. 1, 2, 3, 4. If you were to just move this way, then essentially you're nuking the information that you had in the array, and that's no good. So just be careful when you're doing these things. This is kind of the idea behind insert, is that you're just shifting things over such that you have enough space. And so maybe there's a condition. Well, what if I don't have this extra space here at the end and the array is already full? We'll talk about that in a second. So this was insert singular. I want to make a quick note about the insert multiple. So let's once again draw an array. So we've got this array here. So this is our array, and let's say we've got this data in it, and we want to, at this location, we want to insert instead of just one value, we want to insert multiples. Let's say we're going to insert, let's see, let me look at my notes here. We're going to insert 3 instances of the number 7, right? So if this happened in code, well, what would need to happen is the same. And there's kind of 2 different approaches that you could take. So you could either have like an outer while loop that runs 3 times and performs the singular insert 3 times, or you could be clever, and there's kind of a trick that you can do, which is a little bit more efficient. So what I'm saying is either you can move everything over, so move everything over, and that would look like this, and do the insert, and just do that 3 times. So once again, you move everything over, and you just keep doing that until you have inserted multiple elements. Or what I prefer, which is what I think is actually slightly more efficient, well, not slightly, extremely more efficient, is if you know this number count right here, you actually know how far you have to shift each of these elements, right? So if you have a count of 3, then you know that, okay, well, I need to make 3 spaces. So when I'm moving this over, I need to move it 1, 2, 3, and just immediately move it there with no iteration. And oops. Likewise for this element here, you just move it 3 spaces over. And then that leaves, as you can see, 3 spaces to which we perform our inserts. So I hope conceptually that'll give you kind of a hint as to how you should go about coding this. I will say that this is probably the crux of the assignment, insert multiple. This is probably the hardest thing that you have to do. Some tips is I would think about this in terms of 2 for loops. So I'd have my first for loop, and within this for loop, you're going to be shifting things over. And in the second for loop, you're going to be actually performing multiple inserts. That's kind of how I would structure this. And if you get to this part of the assignment, a lot of students get stuck having segmentation faults in this particular assignment. And so I'm going to give you a hint. It's going to be in one of a few places. So it's either in the, it's going to be the upper bound of this for loop. It'll be in the lower bound of this for loop. It probably won't be here. Yeah, I don't imagine that would give you an issue. It could potentially be if you have a statement like array something is equal to array something else. It could be either of these positions, or likewise, it could be some issue with the parameters in this for loop, or the parameters here. And so knowing that if you are stuck at the insert multiple, I advise you to ask some questions. So particularly down here, how many times are my loops running? And you can actually sit down and do some mathematics, right? You can take your lower bound and your upper bound, and if you do upper minus lower, that'll actually tell you how many times this first for loop is running. And I think logically, because we need to shift a certain amount of times, which is something that you can figure out, right? If we have like, in this example before, if we have two elements to shift, then you need to make sure that upper bound minus lower bound is going to equal 2 in that case, or that amount of times. And then likewise for this loop, how many times is this loop running? Well, that should run count time. So again, this is kind of one of the cruxes of this assignment. Once you get past it, it should be smooth sailing for the most part. And then, okay, so something I brushed past earlier is imagine we've got this instance, right? So imagine we've got 1, 2, 3, 4. Imagine we've got an array that has data in it, and we say myvec insert. We want to insert multiple things here, maybe. I don't know. It's going to put just these random values. We don't have enough space, right? We don't have 5 spots here. So what do? Like I said before, the vector kind of is supposed to wrap up all of these nasty, unpleasant things that you would have to do when working with an array, all kind of in one place. So rather than actually allocating space and copying things over every time you need to add space to your array, the vector takes care of that for you. So you actually have to define a function that'll just be called every time. That function is called grow. And let me give you a little flow chart. So first, is array null pointer. So ask yourself this question: is array null pointer, right? So imagine we're calling insert, and array just points to nothing. Well, in this case, if the answer is yes, then the grow function needs to handle this issue by taking this pointer that we have, which is array, and we need to give it some space. We need to allocate some space. That way we could put something in here, right? If array is not null pointer, then now we're in a separate issue where we have array, which is our pointer, pointing to some valid memory, which is going to represent like this. And we can assume that this this array is full, right? And if array already exists, then what we want is to have an array with more capacity, but with the original values still. So 1, 2, 3, 4, 5, 6, 7. It's kind of traditional in this scope, and we're going to talk about, we're going to talk about this later, why this is, that you just double the capacity every time you need to resize. This turns out to be very efficient in the long run. And if array is not null pointer, the approach you want to take is allocate new space. So I'm going to call this new array. And then we want to copy the values over. So that'll be like this. And then as you can see now, we've got an array that has all the right values and then also the extra space. And what we want to do is we want to deallocate the space that we had for array, change ownership from this pointer to this pointer, and invalidate this pointer. So those things, the list of what I just said, should all be done in code. And by the end of that, we should be looking at this. So this is the grow function. This is kind of the flow chart. And as you can see, by the end, we should be happy. This should take care of things. And when do you call the grow function? You call this an insert. Whenever you run into the situation in which you're trying to insert and you don't have enough capacity. So just, I guess as a quick note, one more time, the vector, like the car, handles a lot of the functions under the hood, including manipulating the value of size and the value of capacity. So every time you perform an insert, something that needs to happen in this code, so not only do you do the shifting and the actual insert, at some point you've got to do size plus plus and actually keep track of these parameters. That way, when you call the insert function, you can actually check, you can look, okay, well, is size equal to capacity? Because if that is true, then you need to call the grow function, right? Or in the insert multiple, let me just get more blank space. If you're in the insert multiple, then you need to be not only checking is size um, greater than capacity, you need to be doing that for maybe a couple repetitions, right? So um, assuming you're trying to insert multiple things, that'll be size plus count being compared to the actual capacity. And while this is true, woo, ah, and while this is true, you're going to actually have to call the grow function. So maybe you have to do this multiple times, right? So maybe your array looks like this, and then it looks like this, and then it looks like this, and then now it's good, okay? So just keep that in mind that for insert singular, you're only ever going to have to call grow once. For insert multiple, you might have to do it a bunch of times. When you're shifting, start from the back of the array. Don't do an iterative shift a bunch of times. Just shift everything by count. Implement this logic for grow in the actual grow function. That way you can just call the grow function because you will need it later. And then make sure you keep track of your size and capacity parameters. So I've lost a lot of wind just talking about the insert functions, kind of yammering on. Hopefully that should be enough to get you started on those. As soon as you've done insert, pushback should be a one-liner. I kid you not. I'm so serious. Um, I completely recommend do not even think about pushback. Do not touch this function until all of your inserts are working. Let's see. So wait until insert, because the motivation of this video, I said, when you have a car and you need to go from point A to point B, don't build the car. Use an existing car, right? So if we have already defined an insert function, don't redefine that insert function. In this pushback function, call insert on end. It's literally that. It is literally this, I promise. Like, actually, let me type it. So it would be insert. I think it asks for the position first. And then literally do this. Please do this. Do not repeat yourself. I do not want to see students submitting code that they've written twice. That is too much work. Do not do the work twice. Please. This is not cheating. I swear. If you can get away with using less code by calling code that you've written previously, that makes you an excellent programmer. So please do this. And I hope you can imagine that it will be the same for popback. So don't actually write logic here. This just, you're gonna call erase on int, right? So hopefully that's clear. Just wanted to get that note out of the way. And then also the grow function that I talked about earlier, the flowchart I gave you, do that here. And please, again, write the logic in the grow function. That way, when you need to call it, you can call it here, and it is only defined once. Imagine that there's a bug, right? So imagine there's a bug with your insert function, and you have written both insert and popback. Well, to fix that bug, you now have to fix two functions. If you do pushback and popback the way I want you to do it, which is I think the more sophisticated way, if there's a bug, you fix it once and it fixes it in both places. So that being said, uh, let's go ahead and move on to erase. So where are we? Oh, and by the way, if you get stuck on any of the things that we were just talking about, here's the technical documentation. So um, one thing I didn't cover is look at the return type. So the return type for this function is an iterator. It's asking you to return an iterator pointing to the position the element should be inserted. So, look at the technical documentation. It'll kind of help you out if you're having some issues. I'm not going to cover the rest of this stuff, I don't think. Erase. Okay, erase. So we've got two erase functions, kind of similar to insert. We've got one, so this is erase, that is for a singular erase, and then one that is for a multiple erase. And so let's see what the doc says. So it says erases an element at position. So we've got an iterator to a position, and we're erasing that element there, and then it should return an iterator pointing to the last element. And then the erase multiple basically just gives us two iterators, and we're supposed to erase everything between those two. So let me go ahead and switch to my iPad one more time. Okay, so now we're talking about erase, and I think once you've done insert, erase is kind of like it's the same trick, kind of. So imagine we've got some array, and I actually think erase is easier than insert. So okay, so we've got data in here. Let's imagine we're calling erase. So uh, we've got this vector, and someone goes along and they want to erase the data at this iterator. Well, what needs to happen is essentially you just move all of the content down a position. So you effectively just have to replace kind of one by one, like in this fashion, all of the elements that are to this direction of the position that you're erasing. And so what does that look like? Let's see. So 2 is going to become it's going to become 3. 3 is going to become 4. And let me point out that there's actually kind of a curious thing with the behavior of this assignment, where we don't actually remove this 4, right? That's not actually what happens. So once we've shifted all of the content that was to the right of the position that we were erasing, once we've shifted all this stuff, you know, I maybe I drew the arrows the wrong way the first time, but once we've shifted everything by one position, we don't actually have to take care of this last element because we can just say size minus minus, right? Or size minus equals 1, right? And so what that's saying is if before size was 5, then as we're traversing this array, we're going to be able to see all of these elements, right? Now that size has lost 1, we have effectively forgotten about everything that is now in the rest of this remaining space. So it's effectively erased because all of our functions will treat this like it's no man's land, like there's no data there. That's erase singular. I think that's pretty straightforward, except for maybe this part as to why this is. If that's bothering you, then think about, I want you to think maybe like, would it be more or less efficient to deal with data in this no man's land? Like, would it actually save us time, or is that just kind of like an OCD thing? So I think in this case, sweeping it under the rug is actually the more efficient answer. So that's what I would go with. And then imagine we've got erase multiple. This is again very similar to insert multiple in the sense that it can be done kind of in a sloppy way. So we've got, so imagine we've got 2 iterators. So we've got the first iterator and the second iterator, and someone goes along and calls the erase multiple. So myvec dot erase, and they pass both of these. I believe that you'll be passing the first iterator as the first parameter, I think. So yeah. So yeah, someone going about their business calls erase multiple. How do we handle it? Well, we've got the same dilemma that we just had previously, right? So what we could do is we could perform a singular insert for however many times this distance is, right? So we could, I mean, not insert, I'm so sorry. We could perform a singular erase, and what that looks like would be this, right? So like we talked about before, and then let me actually update all these values. So that would look like 2, 3, 4, 5, like we did before, and then we could just keep doing this, right? So now we erase, perform a singular erase on the next one, and then we cut this off one more time. So that would look like, forgive me for the speed of this animation. So we could just keep doing that, and then eventually what we would get is we'd get this eventually, and that would take care of it, but that's not super efficient, right? So instead of having to perform the singular insert a bunch of times, what I would rather see you do is what I consider to be a more elegant solution, is we know that we're shifting these things a certain amount, right? Like there's some distance between these two, I'm just going to call it count, which is the number of elements that we're erasing. And if we know this distance, then we can just shift our elements by count immediately. And that's way more efficient, does this in way less time. Uh, yeah, and so that's erase singular and erase multiple. Um, and even in this situation, as soon as we've moved everything by count, this is no man's land. Stuff that is greater than size, we don't care. So you don't actually have to go set these things to 0. That's not necessary. As soon as size runs out, so if in this case size is equal to 2, none of this stuff matters anymore. Having data here, our data structure just treats it as if it's completely gone and it's completely garbage. So don't worry about that. Okay. And then again, once again, make sure you keep track of your private members being size and so on. These should be, I think, relatively a little bit easier than insert. See, what else do we have to talk about? What have we not talked about? So we've got the one-liners, we've got let me talk about these real quick. So this will be an iterator to first element, and then this is iterator to one past last element. So I think these should be pretty simple. I think the only thing we haven't talked about are the rest of the rule of 5. So we've got our copy constructor, we've got our move constructor, we've got our copy assignment. Did I spell it? That's okay, good. And we've got our move assignment. Okay. So the rest of the things we haven't talked about, kind of this little chunk right here. And so we've got our copy constructor, which as you can see takes in another vector as a parameter. This would get called if somebody did, let's see, I have it in my notes. This would get called if somebody did something like this. So vector. So creating a new vector, I'm just going to say it's a vector event for argument's sake, is, let's call it my vector. And let's say that's equal to, actually, hold on, call this my new vector. Some existing. Right, so this is, if this line were to appear in code somewhere, you've got a vector and you're constructing it and say construct it based on this other thing that already exists, then your compiler would look here in your code for this definition, and then likewise we can fill in the move definition, so vector int my moved vector is going to get called if somebody does something like this. Some existing vector. Okay, and so I think earlier in the video I said if you haven't heard of move yet, I'll come back to it. This is me coming back to it. So what is move versus copy? Maybe this is a subject that deserves its own video. So if I make another video about this, I'll go into more detail. Essentially, copy is a deep copy of an object that already exists or whatever it is. And move is a shallow copy designed to save time, but it destroys things in the process. So here, look at this constructor. So we've got a vector constructor that takes a vector, and as you can see, the ampersand here means reference. It takes a vector reference as a parameter. This is copy semantics. And for move semantics, we've got a constructor that takes a vector with 2 ampersands as a reference. And if you're interested to know what this stuff does, or if you want to go deeper into copy versus move, look up R values versus L values. Technically what this is passing in a vector as an R value, which would be like, I don't want to waste your time if you're, not like super into C++ syntax. If you want to go deeper, look up L value, R value. I think it's like, there's a bunch of stuff that you can get into. Anyways, copy constructor, move constructor, and then we've got copy assignment and move assignment. So the only difference between the copy constructor and the copy assignment is that this vector already exists. So imagine we've got, actually I'm going to do this in 2 lines. So we've got a vector that already exists. So my vector, uh, oops. So we've got a vector that already exists. And then we're taking a vector that already exists. Let's say we call the parameter constructor on this just to be fun. And we're taking this vector that already exists, and we are replacing it with a copy of something else, so some existing vector. And it's the same idea for move assignment. So the only difference between move assignment and move construction is that if you are constructing the vector, i.e. it doesn't exist yet, then the compiler will look for a move constructor. Whereas if you have something in the namespace that is already existing, so like we have here, so vector, my vector, something that already exists, and then you move something new into it, so my vector is equal to st move some existing vector. If you were to call this in code, then that would look here instead of your constructor. And so let me switch to my iPad one final time to kind of walk through what needs to happen here. See. Okay, so for our copy semantics, we've got our copy constructor. And in this case, we've got some old array which we're copying, right? And it's got some data or whatever. And we are constructing a new array. Actually, old is bad. Let me call this other. We're constructing a new array, and we want it to be identical to the one that we're copying. So basically, just one at a time, we iterate and put the data members over, such that our new object looks exactly like the other object. So that's our copy constructor. For copy assignment, let's see, assignment, we actually start with a different place. So we've got an existing vector, so an old vector that we have to destroy, and then we make a new vector based on these values, and it's a copy. So that's copy assignment, copy construction. Let's talk about move construction. Let's see, move construction. So we've got a new array, and essentially all we do here is we allocate a new pointer. Well, not allocate. I'm sorry, I need to be careful with my words. We create a new pointer. We say this pointer gets access to the data that the other one has access to, which is a shallow copy, if you remember. And then we say the other pointer has access to nothing. And so effectively what we've done with our move constructor is we've moved ownership, right? So the array itself actually stayed in place, but now the new thing has ownership and the old thing has nothing. And then as a final thought, oops, I'm going to talk about the move assignment. Let's see, move assignment. And in which case we've got an old array. Oops. And we're going to first deallocate this, and then we're going to make a new pointer, and then we're going to change ownership. And yeah, that should be good. So if you've see, stop. So if you've stuck with it through the whole video, hopefully the assignment should be at least reasonable. I think that's everything that I wanted to go over in this video. I think if you have questions, please like reach out. If something in this video was too fast or not coherent, believe me, you will not hurt my feelings if you say, hey, could you please explain this in more detail? The video didn't go over it well enough. I'd be more than happy to make supplemental material if needed. So I think particularly I really glanced over iterators and I really glanced over move semantics, what that is specifically. So, if enough people are having these issues, I will absolutely make more material. Um, Again, if you've made it through this video, best of luck with the assignment. I'm excited to have you here in the course. Yeah, I think that's about all I had to say. So, yeah, best of luck. I hope you're well.